Next up, number 4, fx. Oh, let's go back just for. Okay, f of x equals x plus 2, g of x equals negative 3x plus 10. Probably the most important thing that you'll need to know here is just that f of x and g of x. These are just names of functions, but basically they're the same as y. They're an output, just the same as y as an output. So we could write these as y equals x plus 2 and y equals negative 3x plus 10, which makes our job fairly simple because we don't have to do any work to get y by itself. If we wanted to graph these, draw our little graph there, we know that this first equation goes through 0, 2. So let's do that one in green. So 1, 2, there's 0, 2. And then our slope, in this case, since it's 1, our slope would be 1 over 1. So our rise would be 1, and our run would be 1. So it should look something like that. And then for the second one, let's do that one in red. We know it goes through 0, 10. And the slope is negative 3 over 1. So 0, 10, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0, 10 there, and then we're going to go down 3, 1, 2, 3, and then over 1 from that point. So our graph should look like that. And this one has, again, just one intersection point, so this is going to be consistent. That's how we classify this one. Next up, 7u plus v equals 5. And the thing that may be a little confusing on this one is that we're not using x and y. But just like where we had the f of x and the g of x, we can maybe switch out these variables if we'd like. X and y, you might notice those are in alphabetical order. X, Y, Z, like that. So if we were doing u and v, then we'd do that in alphabetical order also, and this would be u first and then v. So the x corresponds to the u, the y corresponds to the v. In other words, we want to get, instead of getting y by itself, we want to get v by itself. That way we can tell what the slope is, we can tell what the y-intercept is. If we're working to get v by itself on this one, all we have to do is subtract 7u. So we've got v equals negative 7u plus 5. If we're doing some work to get that one by itself, 7u equals v plus 9. A couple different ways you could do this. What I would do, and this is, some people don't like doing this, but I'm just going to leave the v on the right side and then get it by itself by subtracting 9. Bring down the equal sign on the right side. Now all we've got is v, and on the left side we've got 7u minus 9. It's a little bit different than we typically see it, and you could rewrite it from there. V equals 7u minus 9. Those two are the same thing. So in this case, goes through 0, 5, and the slope is negative 7 over 1. On this one, goes through 0, negative 9. Let's do that in a different color. And the slope is 7 over 1. Okay, 0, 5, 1, 2, 3, 4, 5. 0, 5, and then we're going to go down 7 over 1. So 1, 2, 3, 4, 5, 6, 7, and then over 1. And then for the other one, 0, negative 9. So 0 on the x-axis, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9. That's our 0, -9. And then from there, we're going up 7 from that point. 1, 2, 3, 4, 5, 6, 7. And then over 1. And again, we've got only one intersection, so this is consistent. Number 6, 5x minus 8y equals -40. 8y minus 5x equals 40. So this one a little bit more straightforward. We want to get y by itself again. 5x minus 8y equals -40. Subtract 5x. Oops, 5x. -8y equals -5x minus 40. Divide by -8. -5 over -8 is just becomes positive. And then -40 over -8 becomes positive also. 40 over 8 is just 5. Five over 8 x, and then plus 40 over 8. 40 over 8 ends up being 5. And then we'll put a little star next to this one because you might notice at this point we've got y equals 5x, or 5/8 x plus 5, and we've got y equals 5/8 x plus 5. And what might strike you about that is this is the exact same line. It's going to graph exactly the same way. So we know it goes through 0, 5, and we know its slope is 5 over 8. So we're going to rise 5 and then run 8. So if we're graphing this, we got our 0, 5, 1, 2, 3, 4, 5. And then we're going to rise 5 from that. Let's do this in a different color. Rise 5, 1, 2, 3, 4, 5, and then run 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the first line. And we don't even need to bother doing the second line because they're exactly the same. These two equations are exactly the same. So their lines are going to be exactly the same. And like we talked about on the second slide, if the lines are exactly the same, that means they're dependent. And this, in this case, you know, we talked about solutions being the intersection point. This would have an infinite number of intersection points and therefore an infinite number of solutions. Okay, in our last example, I'll put a little star next to this one just because you might notice if we look at this one, this x equals 4, we're missing a y. And if you look at this one, the y equals -9, we're missing an x. And there are a variety of different ways to solve all these problems. And for this one in particular, I think it's much easier just to pick 2 points, 2 ordered pairs. So let's see here. Let me erase a bit. Well, let's just look at this one. the y equals -9. If we wanted to, all we need are 2 points to graph these lines. So for this one, we need 2 ordered pairs, and it's easy enough. We know y is equal to -9, so as long as in our 2 points, y is -9, it does not matter what we put in for x. So you might just choose 0 and 1, and then you're done. You just have to plot both of those points, and that's your line there. Same with the x equals 4. We just need 2 points to graph that. So we could pick 2 points like this. The one thing that we'd have to be sure about both those points is that x is 4. And just a reminder, these are always x and then y, x and then y. And it wouldn't necessarily matter what we put in for y, 0, 1, as long as x equals 4, and on the other 2 points, y equals -9. Okay, so for the green one, the x equals 4. We know we got 4 zeros, so 1, 2, 3, 4, and then 0, so that's that point. And the other one we got 4, 1, so over 4, 1, 2, 3, 4, and then up 1. So that graph's going to be a vertical line. And then for the y equals -9, we got 0, -9. Zero, -9, and then 1, so over 1, and then down 9. So that'd be our other point. So that graphs something like that. These do have one intersection point, so this would be consistent. And that's all that we'd need to do.